evaluate the limit as x approaches 0 of sine of 3x times sine of 5x over x squared. All right, I'm going to rewrite this down here, but as I do so, let's talk about it. In this example, we actually have two different sines. We have sine of 3x and sine of 5x. And so we're going to want to have in the denominator a 3x and a 5x so that we can have both of those be sine of something over the same thing. So because we're going to need a 3 and a 5 in the denominator, we're going to multiply the top and bottom by 15, which is 3 times 5. And then we're going to do some rearranging. So we still have the limit as x approaches 0, but let's see, we've got sine of 3x times sine of 5x. In the denominator, I'm going to focus on the denominator for a moment. We've got 15x squared, but 15x squared is the same as 3x times 5x. I think you can see why I'm writing it like that. And then we still have 15 in the numerator, so that's times 15 over 1. Now, what we can do is we can pull the constant multiplier out front and recognize that the limit of a product, sine of 3x over 3x times sine of 5x over 5x, is the same as the product of the limits. So putting that 15 out front and splitting this limit of a product into the product of limits, we've got the limit as x approaches 0 of sine of 3x over 3x times the limit as x approaches 0 of sine of 5x over 5x. And I think we've looked at enough examples now that you'll know that both of these limits are equal to 1. We could make u and v substitutions, letting u be 3x and v be 5x. But we know that as x goes to 0, so does 3x and so does 5x. So we know that those are going to work out. Both of those limits are going to be equal to 1. And 15 times 1 times 1 is 15.